See, the electron, which was thought of as a particle cathode ray tube ionotrope experiment, also exhibit wave-like properties. Quantum numbers need to four to fully describe the electron. The principal quantum number, orbital angular momentum quantum number, magnetic orbital quantum number, spin quantum number, and principal quantum number. Let us discuss it in detail. It designates level or shell, now viewed as cloud. Also, the second point describes that it is a prime indicator of the electron's energy. The energy of electron. Its primary indicator is mainly the principal quantum number. Alright. Afterwards, we discussed that it can have values ranges from 1 to 3 up to so on 10 etc. so on going on, right? Then we have orbital angular momentum quantum number. It also designates sublevel, subshell, subshell, energy shell, orbital energy level, etc. These are different names for sublevel that localize the particular is a sublevel, that is S, P, D, etc. Alright. In the second portion, it describes that it is the secondary indicator of the electron's energy. So the primary indicator was the principal quantum number, and the secondary indicator of the electron's energy is the orbital angular momentum quantum number. And the orbital angular momentum quantum number or azimuthal quantum number can have values 0, 1, 2, n-1. Also, orbital angular momentum quantum number or the azimuthal quantum number can have integral element L 0, 1, 2, 3, which has specific orbitals S, P, D, F, etc. So those explanations were all about discussing designation level, electron energy secondary indicator, value 0, 1, 2, 3 up to n-1. n-1 is the basic formula for finding out a proper azimuthal quantum number for an indicated sublevel, subshell, or quantum shell, which is also called quantum shell, because being derived or discussed by azimuthal quantum number. Alright. So that was our general explanation about azimuthal quantum number. Remember this table. It will be useful in the future for discussing. Also, in detail, we have electron probability regions known as the clouds. 1s, 2s, 3s, which we will be discussed in the next lecture also. 3pz, 2pz, 2py, 2px, which are three-dimensional. Furthermore, we will express a detailed note for determining n and l quantum numbers. We have notation for an indicator. For 1 we have P. For 0 we have S. For D we have 2. For 3 we have F. Vice versa. Afterwards, give the quantum numbers for 3D sublevel. So it's like a question from us. As you can see, the orbital quantum number is 2. Then the quantum numbers as indicators for electron energy. Quantum number as indicators for electron energy. So the energy, which is of the sublevel, increases with n+1 azimuthal quantum number. Alright. Which sublevel is higher in energy? Is it 3p or is it 3d? So let us think about their quantum numbers. First of all, discuss principal quantum number, then azimuthal quantum number. So the primary indicator says 3p equals 3, Also for 3D we have n equals 3 plus L equals 1. The secondary indicator says that for 3p I have value L which equals 1. For 3D, the secondary indicator expresses itself that it equals 2. So, summing up both the values, we will gain 4 on the left side, 5 on the right side. So, saying to their comparison contrast, we have 4 smaller than 5 obviously. Afterwards, on the next page we have quantum numbers as indicators for the electron energy. The energy of the sublevel increases. Remember that the energy of the sublevel, sorry for that interruption, but the energy of the sublevel always increases. We have to remember that the energy of the sublevel increases. The energy of the sublevel increases with n plus 1, which we had discussed already in the first or in the previous page. Which sublevel is higher in energy? Is it 3p or 3d? So if an electron makes a transition, mean if it excites, de-excites depending on its position. So in this case we have excitation of an electron which is making a proper transition from the 3d sublevel to the 3p sublevel. Will it indeed to absorb energy or emit energy? So what is your question? I am asking this context, what is its question? Is the electron need to absorb energy or either it needs to emit energy for transition from 3D, for its transition from 3D to 3p? So in this case we have a transition being done from 3D to 3p. So obviously the electron will absorb sorry for my apologies, or excuse me from my listeners. Okay, sorry. So in this case we have, will it indeed to absorb energy or emit energy? So it is always encircled that the higher energy is this one, so it will emit energy. It will emit energy. The sublevel which is higher in energy is 3D, so it will emit energy to get de-excite from 3p sublevel, from 3D sublevel during transition to a 3p sublevel. Alright, let us presume to our next page. Quantum numbers, which are 4 types, we discussed through as indicators: the primary indicator, the principal quantum number, and the secondary quantum number. The secondary indicator of electron energy level for electron energy. Alright, for electron energy, the energy of the sublevel increases. The energy of the sublevel increases with n plus 1. So which sublevel is higher in energy? Is it 5f or 7s? What do you think of? So the solution has been given. You can derive your answer from the solution very quite easily, but let us derive it. We have principal quantum number for 5p orbital, which is 5, and azimuthal quantum number, which is 3. For 7s orbital, primary indicator have 7 value and the secondary indicator have 0 value. Afterwards, adding both the values in here and on the right side too, we will get 8 greater than 7, which will give us a proof that the energy of the 5f sublevel is much greater than the energy of the 7s sublevel. So let us proceed to our next page. Quantum numbers are indicators for electron energy. The energy of the sublevel increases with n plus 1. So always when a question is asked that which sublevel is higher in energy, so you will say that any, so you can easily answer that question that any sublevel with increased or with exceeded n plus l value will obviously have highest energy than the one sublevel having low n plus l or secondary indicator plus 1 value. Alright, if an electron makes a transition from the 7s sublevel to the 5f sublevel, will it need to absorb energy or emit energy? So the answer has been indicated here, but let us discuss. As the 7s sublevel having low azimuthal quantum number or secondary indicator value, so 7s sublevel will always absorb energy to get excited, to jump, or to get transitioned from its home 7s sublevel to the 5f sublevel. Let us take a review over the quantum numbers. First one and second one. Principal one, it has restriction, it has values ranging from 1 to 3 and so on. Orbital quantum number, it indicates the electron sublevel in most of the cases. Also, it describes shape of electrons probability regions, which we call electron clouds or simply orbitals. Alright, and the restriction for the secondary indicator is that L equals 0 to n minus 1. The values of the secondary indicator ranges from L equals 0 to n minus 1, and L will always be less than principal quantum number. Magnetic orbital quantum number and spin quantum number will be our next topic of our next lecture, which will I upload in the next video. Hope you are doing well, you are learning well. If you have any queries relating to the lecture or method, you can ask.